I'm an AP Stats. AP Stats. I'm an AP Stats. I'm an AP Stats. I'm happy that I'm in AP Stats. AP Stats. Okie dokie. So, hey guys. As you can see, we are working on right now 1.2 quantitative variable graphs. AP Stats. Okay, I love that song. Anyway, I want you guys to turn to your notes. Let's go to page 6. Now, when it comes to quantitative variables, we have to do what's called pay attention to our socks. So, make sure it's a clean pair now. Now, everything that we've done up until this point has all been categorical. But now we're about to talk about using our numbers, quantitative variables. And when we're looking at the idea of quantitative, we always have to look at our socks. And like I said a couple seconds ago, white socks are really cool. Socks is a mnemonic that represents for us shape, outlier, and center and spread. It tells us or describes our distribution. So remember, distribution is just data. And yes, when we have the data going in a picture, that is also another form of a distribution. When it comes to the first S, symmetry. And as we look at symmetry, we can see here that we have 3 types of shapes. We have symmetric, we have right skewed, in which the predominant information is on the left side. It's the opposite of the way it appears. So as I slide this over right here, you see this is right skewed. And yes, I know it's the opposite of the way you think the information is on the left. People say it's right skewed because it's pushed from the right. Now, as I go back to the notes, here the idea of left skewed. The majority of the data is on the right. So here, this is an idea of left skewed. So as I said a minute ago, it is the opposite of the way it appears. This right here is right skewed. This right here is left skewed. And of course, we all recognize what symmetry means. You gotta love Google being able to find this stuff. Now, as we go back to my hideous pictures, yes, I want to discard. The whole premise behind this is that if I have things that are symmetric, that means yes, I have winners and yes, I have losers. Things are balanced. When I have something that is right skewed right here, which means the predominant information is on the left, that means I have lower values. And then when I have left skewed, that means the most of the information is on the right. That means I have higher values. So like if it's coming to your income, you want it to be left skewed, higher income. If I'm in debt, I want my debt to be right skewed. I want to have lower debts. And symmetry is, I'm looking at where the average is. The O of our socks is an outlier. Extreme values, high or low. So Bill Gates, he's an outlier. Center, as I look here and I look at, center is referred to as the average, the median, And when do we use the average, which is represented by X bar here, or the median? It really depends on the distribution, and we'll be working on that as time goes on. Some people look at, when I noticed the book, it also referred to the midpoint when we were doing dot plots, which you're going to be doing in the middle. Okay, I'm still sticking to the terminology median though. And spread. Spread is variability. Remember, variability is range. You guys have seen before the word standard deviation at some point prior to this class. Okay, standard deviation gives you how far away you are from the mean. We are going to be, chapter 2 is all about the introduction and the solidifying of standard deviation. Also, another thing that measures spread or variability is IQR, the interquartile range, which we'll be talking about when we look at our box plots. So the bottom line here is that we need, when we are describing a distribution, we have to put on our socks. Now, right here, I want you guys to cross this out, and we're going to use some of the data that we had from the computer, from the surveys that I took. You don't have to go online. I'm just going to give it to you in a minute. Okay, so here it is. Take a minute to write it down for both the males and the females. Now, what a dot plot is exactly what you see, or what it says, I should say. You're going to be drawing a line, and you're going to be putting dots that represent the data. So go ahead and draw a line, and then let's go ahead and label our x-axis. Now, I'm going to do the females just because I feel like it. And as I do this, please recognize our numbers range from what? It looks like 53 to, what is it, 65, 67, 71. So as I put my numbers right here, I'm going to make increments that are reasonable. And it does not have to represent all of the numbers exactly as it is here. Okay, now all I'm going to do is find 48. 48, duh. Let me back up a little. I need a 45, don't I? Yeah. Okay, so 48 is going to be about here. 53 is going to be about there. And then 54 is going to be about here. And then we're going to keep going until we fill out this entire dot plot. Now, as we look at this dot plot, it really doesn't tell me much about anything. Yes, I can figure out my center is, how many are there? 1, 2, 3, 4, 5, 6. Is 1, 2, 3, 4, 5, 6. Yes, here is my center. Yes, I can determine my spread ranges from what, 45, nope, wrong, from 48 to 71. So here's my spread, 48 to 71. I can see it doesn't look like there's any extreme values, outliers. Okay, and if we really want to push our luck, we can say it looks like there's a few more pieces of data on this side, which is on our right, which means it appears to be left skewed. But this is the problem. It just looks like it's a bunch of dots here. There's no line, nothing lined up. So the reality is this is not a very good picture at all to help me be more specific about our information. So that means instead of doing this, I'm going to try doing this another way. I am now going to make a stem plot. And as I make a stem plot, this is another way to represent quantitative data, in which here what goes on this side is the stem, and what goes here is the leaf. What the stem is basically a common number, and the leaf are the easiest way to explain a leaf are the leftover numbers, the leftover parts of the number. And the stem is usually the leading part of the number. So now I'm about to draw a vertical line. And as I look at these values of these height in inches, I've got 48, I've got 50, I've got 63. So here, I'm going to write a 4, I'm going to write a 5, and I'm going to write a 6. And now, here, if this is a 48, and I need to know I've got a 48, a 47, and as I write these numbers down, I need to put them in numerical order. So here, like I said, I see 48, 47. Are there any others? So here's 47, 48. Then I look at my 50s. I have 53, 54, 56. So 53, 54, 56. Oh, I left my 70 off, didn't I? Add that to it. Then I do the same thing to my 70, and I do the same thing to my the ones that are in the 60s. Okay, this is what I have. Now, the one thing about a stem plot is that we need to make sure we have what's called a key. So, because if I just gave you this, you'll go, hey, Yarborough, what is that? Okay, well, let's make a key here. And the key says if I have 47/7, that equals 47 inches. And this is the height of females. Okay, but it's a nice way to organize the data, and it's you saw all I did was just cross things out so I don't lose my step. Now what I'm going to do, oh, and before I continue, let's look at the idea of the skewness. Now I like to twist this around, and I can still see that the majority of the data is on the right side, which means it's left skewed. I still see no outliers. There were 12, so 1, 2, 3, 4, 5, 6. Okay, the median height looks like it is about 60 inches, which is 5 feet. So in analyzing this, we would say in this particular group or distribution that I took, it seems like the median average is about 60 inches, in which the data appears to be left skewed because it seems like for our distribution, most of the heights are on the taller version of our distribution. The range of scores would go, or range of heights would go from 47 to 71 inches, and it does not appear to be any outliers. There is, I know some of you guys are saying, well, outliers only, is it visible, or is there a formula? Yes, there's an outlier formula that's coming up when we get to box plots, but not yet. So the next thing I want to talk about is the idea of, what if I want to do a comparison? And as I do a comparison, I want to do a back-to-back box plot. So I'm going to compare the females to the males. So get that ruler out. Okay, so please notice what I've done. I've put in the middle my stem, because I'm going to have females on this side. I'm going to squeeze males in over here. And now I'm going to do the exact same thing, the same way that I made this stem plot for the females. I want to do the same thing for the males, except this time I'm going to put it on this side. Okay, let's see what this looks like. So here are my males, here are my females, and I'm going to use the same key. And if I use the same key, that means I'm going to have to take out the word of females, that phrase, and that works for me. Now, so that's telling us I've got 54, check, 57, check, and notice that they're in numerical order. Now, as I'm reading the females, remember it goes in this direction, 47, 48. I've got the lower heights on the left side, just like a number line. But when I'm looking at the males, it is the opposite. I've got the lower heights right here on the right side, which means as you look at this, if I were to rewrite this, this is what it's going to look like. It looks like this. Now, the reason is, remember, we read our number line from small to large, from left to right. And because we made it back to back, and this is an empty spot, by the way, that means that now we can see here that it does appear that the majority of the data is on the right, which means it's left skewed. As we look at this right here, it looks like the majority of the data is on the left, making it right skewed, but that's a no, no, no. Because of the orders of the numbers being reversed, it's the flip. So, with that being said, let's make a note that yes, there are no outliers. It appears that the range is from 54 inches, these are talking about males, to 75 inches. But what's more important to me right now is the idea that you recognize the skewness on this. That this right here is your skewness, that this is left skewed. And remember, it's the reason that it's left skewed is because it's the reverse of the way it looks. The two major things here is that as we look at the idea of a stem plot, it's an easy way of organizing things. We can see how we can group it. We can see how the distribution is described in the distribution with our socks. But if we have a large data set, and let's say we have something like this, and I didn't mean to draw this, you have, I'm going to use pink dots to represent the numbers. So you can have, large data sets like this, and exactly what is that going to really tell you? You know what I mean? So in a case like that, you might have to do what's called split it, which I'll show you in a couple seconds. And that takes it to the exact same premise that I'm saying right here. Repeating the values also distort the graph. So sometimes, let's say that you have this particular data set, and I'm just going to do a quickie. Okay, so look what I have here. Look at this new data set that I just happened to write down. So it's a random data set. And look at these numbers. And as you look at these numbers, there's a lot of 40s and there's a lot of 46s. And I just got lazy. I just didn't want to write down anymore. I'll stick one more in there. But as we do that, we're better off splitting this because we'd have some type of a tall building, like the Sears Tower, 100 floors or something. And instead, if we split it, and we can split this into half and half, meaning make this like 40 to 45 and then 46 to 49. So split the digits like that. So here's 41, here's 42, here's 44, here's 44. Okay, now 46 is going to go over here, 49 is going to go over there. As we look at 50, if I split it there, I've got to split this also. So this is a 1 and this is a 3. And then next, notice I have a 63. And I know your thoughts are, well, Yarbrough, do I put a 0 there? And the answer is no, because if you put a 0 there, doesn't that represent 50? So you just leave it blank. And the same would be the case in any other type of stem, whether it's a split one or whether it's a back-to-back or any type of stem plot. You don't fill in a 0 for an empty spot. You just got a gap there, and it is what it is. Now, turn your notes to page 7, and as you go to page 7, please read that. Okay, so you can see right here we have dot plots that represent energy cost of, we have a top freezer, refrigerator with a top freezer versus a refrigerator with a bottom freezer, and trying to see which one that's more efficient in terms of cost, energy efficient in terms of cost, and this data was collected in May of 2010 from Consumer Reports. We have to do an analysis. So as I look at the idea of my socks, so as I look at this one right here, you can see it appears that this is left skewed because it appears that the data is shifted over to the left. An argument could be made that it's, I'm just going to say, it's definitely not symmetric, but I'm just going to put the word slight. The median, all I did was sit there and count the number of circles, and it looks like that's in the median, the middle. The spread, it looks like the spread ranges from 42 approximately to 154. Where am I getting those numbers from here? And how did I figure out those numbers? If I'm off a little, so be it. And the AP test won't nail you for that either. It's okay, because all I'm doing is looking at increments of 14 right there. The outliers, notice your outliers, your extreme values are in red. Now, that is for the freezer that's at the refrigerator has a freezer at the bottom. Now let's look at the one that has a the freezer at the top. Well, it looks like to me that it is approximately symmetric. There are no outliers. My range goes from, what does it go? My range is from 43-ish to 68-ish. And if I'm off a little, it's okay. So I've got my S for my symmetry, my O for my outlier, my other S for my spread, and it looks like to me my center is, again counting, looks like my center is right there, which is about 56. But after gathering all that data, what is the point? That's just a bunch of words now. The beauty of stats and the pain of stats is pulling it all together. So, if they give you two distributions, they expect you to compare and contrast. As you're looking at two colleges, aren't you comparing and contrasting to see what's the difference, what works for you and what doesn't? Okay, so based on this data, and the reason that's important is because different data is going to give you different output. It appears that the energy cost of the freezer that's at the bottom has a higher median average. I put down the price that there, has more variability. Okay, then I gave you what the variability was, and it has high-end outliers, and I named what those high-end outliers are. Okay, and after all of that, what does that do here, which confirms with all of this also, can't forget about, it's the idea that it's right skewed. Now your thoughts are, Yarbrough, you haven't done any comparing and contrasting, you're just talking about the bottom freezer. That's true. Now I'm going to talk about the top freezer though. And as I talk about the top freezer, here I've got the top freezer seems to be more energy efficient because the median cost is approximately $56, so that's $14 less than the other type of freezer. Okay, it is also more symmetric, remember, which means it's more balanced in terms of the samples. It's remember when you have something that if it's more balanced, you have consistency. And speaking of consistency, here we have less variability with your samples, so it's not as flaky. And yes, I didn't forget about it, it doesn't have any outliers. So this tells you that if you had to choose a refrigerator type right now, that you're better off going with the one that has a freezer at the top because it is more energy efficient. Now let's go to the next problem. We're going to make a stem plot. And as I make this stem plot, you can see here is my key. I've got my values right here. And I mentioned gaps before, but as I write this down, 3, 8, there's a 5. Here, there's another 300. There is, and all I'm going to do is plug in all this information. And here's the results. Again, things are so spread out. Looks like 460 is an outlier. The data is on the left side, so this appears to be right skewed. And the one that's in the middle is 1, 2, 3, 4, 5. So it looks like 330 is the median life of the battery. Now, as we look at the dot plot, as we compare and contrast the two, the beauty of, well, the stem plot, I mentioned the key, but the stem plot, look how large it is. It doesn't give you as clear as a picture. But when it comes to the dot plot, we can squeeze those values in a little bit more. So now let's make our dot plot. Okay, now yes, as you look at this dot plot, yeah, I know it's not dots, but whatever, I used a highlighter. Okay, but as I look at this, now we can see a little bit more of a pattern. We can see that that's definitely an outlier. It was obvious there too, let's face it. Okay, we can see that this is, again, right skewed. The majority of the data is on the left side. We're going to come up with the same median, the same range, but at least the picture is not as spread out, so it gives us I want to say, a clearer sense of what's happening. So it appears as we come up with, if I had to analyze this, which I will have to, I would say that based on our distribution, because that's key, so given the data that we have right here, it seems like the median average of the battery life, again, of the batteries that we were, of these particular smartphones, phones, and it is 330 minutes. It appears that the range of battery life is going to go from 300 to 480. With an outlier, 300 to 460, with an outlier of, looks like 460 minutes. And my spread, I think I covered everything. So I didn't say straight up, I don't think that it was right skewed, but yes, it is right skewed, with meaning the phones that I have lower battery life, which I know that's true of my phone. I don't know about yours. Okay. Last one that we're going to do, Olympics. Okay, yeah, I can't sing. Now, I'm sure as you read this, you're like, where is the data? The data is either on the next page, or you can refer to page 8 of your notes, or on page 41 of the book. Now, we are talking about the Olympic medals, and of course we're not talking about the current ones, and all the countries and how many golds they received. And for the sake of time, this is straight out of your book, the graph. They did increments of 7 because they felt like it, no other reason. I would have done increments of 5, number makes more sense. But now the whole premise is, now we need to do the analyzing of the information. Okay, so as I look here, the distribution is strongly right skewed. And yes, you saw that it peaked at 0 metals. The median appeared to be 1 gold medal, with the range that went from 0 gold medals to 46, in which, yes, we had some obvious outliers of Great Britain, China, and the U.S., with their medals being 29, 38, and 46 respectively. There's your analysis. So that's saying that yes, on average, not that many countries received a lot of medals. Because even though we have these countries like us that received a lot, that was, again, an outlier. Now, as I wrap this up, because this thing is way too long, read this question. And the premise is here that, okay, we had 205 countries that participated in 2011, 54 won at least 1 gold medal. Do you believe that the sample of the countries listed is representative of a larger population? And the answer is no, 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 no. Okay, and the reason is because our sample, we had 19 out of 30 countries who won a gold medal. They said in that Olympics right there that 54 out of 205 won a gold. So only 26% won the gold in 2012, whereas for, and I didn't write it down, let me get a calculator, 19 divided by 30. This one is 63%. Our group, 63% won a gold medal. So no, it is not a good representative sample. The percentages are just way too off. Okay, a lot of notes. I'll send you a reminder to let you know where this is. Have a great weekend. Bye-bye.